Okay, so I've been doing a lot of work on the latest DragonOS FocalX ISO and nearly finished. I'm waiting for a few more things, but something that is really cool is this new feature for the BladeRF. And so this has been a long time in the making. I won't go into all the details. I just been messing with it for a little bit. I recall it discussed before, but anyways, so in DragonOS, I have already taken and placed the latest FPGA files that are needed. The libbladerf, I've kind of gutted out what the app system had provided, and now have this latest release in here. And so this feature will be in DragonOS, and the feature is basically enabling a mode with the BladeRF to get up to it's about like 122.88 megasamples per second. The bandwidth through this 8-bit format mode and oversampling feature. Okay, so what does all that mean? So I'll show it here, and what I want to show is its use with GR-Osmosdr, which I've modified, and anything that basically uses that will be able to use this feature. I'll show GQRX, and then SatDump. As of this video, I know SDR++ and some other things will probably either already have or will have this feature, so I'll build it in there. And then something else I think is pretty cool is which I've had it in DragonOS release, probably the last release or so. I just hadn't talked about it. Is the Ice9 Bluetooth scanner, which talking with well, I just seeing the mention that maybe that would be included as a capture source in Kismet really has interested me, getting more SDRs into Kismet. Anyway, so enough of me talking. Let's take a look at this feature here. Let's just start with GQRX for example here. So I have a bladeRFxA9 plugged in. Everything will occur, automatically through DragonOS. So the loading of the FPGA will be handled. And so we want to select, we'll use the one that's the GR-Osmosdr, which typically will have this shorter device string and does not mention SOAPy in it. And then what we'll do is we'll pass the additional arguments that are needed to enable this mode and really increase the bandwidth and sample rate. So sample format equals 8, and we'll do feature equals over sample. I'll go ahead and just manually punch this in. I'll just go with 122 megasamples per second. I'll leave bandwidth at 0, so it should just be the whole range there. If you look, I'm running this via the command line just so you can kind of see what's going on behind the scenes here. So oversample feature enabled, sample set to 8. It will clamp the gain, I think, to 11. So you might need to mess with the gain settings a little bit here in GQRX. I'm not super familiar with them, but let's say we put this on 2.4 gigahertz center here. So now we're going to be looking at 122. So we should be able to see all of Bluetooth, for example. And again, you might have to mess with gain here. So I don't know. We'll figure this out. And let's start this up. So now we're looking at that entire range there, and so you probably see some activity. Let's see. I don't necessarily need any demod on, but so Bluetooth. I can kick that on. You do see some activity across the entire range here, and again, you might have to tweak your gain settings, and so you can just mess with that. But I don't know. That just like it's crazy that that has that wide of a range out of that BladeRF. So that's with GQRX, but you can see what is needed for GR-Osmosdr. So you could pass that along to other programs, and I'll show that here in a second, which I think it applies. Let me clear this out. Oh, and you can see the gain clamped to 11, like I said. So let's clear this out. Let's take a look at the SatDump UI. This is already built in here, and so I don't have anything hooked up to actually demod anything with SatDump at the moment, but I just wanted to show it does have the 122.88 there, RX1. That's fine, and let's just take a look. I'll just show that it's working. And you might have to come down here to the FFT minimum and lower that down some. Now that's on, what is that, on 100 megahertz, so you know that I'm trying to think either side. I think the BladeRF, the minimum is maybe 70 megahertz. I can't remember, but so you can change start and stop. You can see that it is actually using that entire range of 122 meg, like I said. So there's SatDump, GQRX, and so I'll show use of this other application here, which is already in DragonOS. I was kind of looking at the page here. This Ice9 Bluetooth Sniffer, the directions are slightly different than how it actually is used. And so you see this comment that kind of sticks out there. So again, it's built into DragonOS. I'll go ahead and show, if you wanted, you can clone it down separately, and I'll just point out why. It's actually in the user source Ice9, so part of the ISO. You can see I've already built it. There's the executable. Now I've copied that into the user bin, or maybe the user local bin directory, so that it's available system wide, so I can just run Ice9. But it's actually Ice9 Bluetooth. If you want to do like what the directions talk about, where you can open up Wireshark and have it as an interface, you could just as easily make directory build, the typical make a directory build, cmake, and then and so if we built this, which doesn't really take long, and you make install as a normal user, you'll see that it copies it to your home directory in .config Wireshark. And so if you, I think theoretically, if you opened up the Wireshark, you can see that the Ice9 Bluetooth BladeRF is there, and you can use it right there. But what I want to do is show its usage. And I'll clean up these windows here. We'll go to our home directory. I'll show its use outside of Wireshark. And so I'm not 100% sure, but I would like to think that by doing this Ice9 Bluetooth, let's do a -I of the interface BladeRF equals 0, sample format equals 8, like I talked about, and then feature equals oversample. Now I kind of got this from the BladeRF, or the Kismet gentleman kind of clued me in on this, and so I find it very interesting. I'm going to add a -S. -V is for verbose, -S is for, I think it's for stats, so we'll be able to see this working, which I know this particular desktop doesn't have a crazy amount of power, so it's probably going to pump out quite a few warnings there. But so I'm going to try and run this Bluetooth device using the BladeRF under the assumption that if I'm passing this sample format, feature oversample, and -C of 40 channels, I'm thinking that I'm looking at all 40 channels at once, perhaps. So you could see, I get the channelizer too slow, use fewer channels. But let me turn on and off so we get some burst there. I'll turn on. Turning on Bluetooth. So what should be happening now is this is being saved to the PCAP file, which we can open in Wireshark and then see this Bluetooth activity. So I'm going to open that up. I'll probably blur out the MAC addresses, but I have seen that this is working. And again, your performance may vary depending on the specs that you're using to run this. Okay, so I'll close it out, and let's open that up in Wireshark, maybe. Ah, actually, that's my mistake there. So that should have been a dash W. Actually writing that and not just. Let me go in a directory that I own, and so we'll do a dash W and we'll write that. The other I was just pumping it out to the screen there. So let's do this one more time. And so there's the burst. Just turning it on and off. I'm sure there's other Bluetooth around here. And so now let's save this and we'll open up that PCAP file. And so there we go. I didn't run it very long. We can see if we go under our Bluetooth low energy info, we got our advertising channel. And so, yeah, there you go. And the source and destination I've just blurred out just because there's MAC addresses there. But what I'm excited is having this all in DragonOS and then hopefully seeing some integration into Kismet. Yeah, and so when any other applications take advantage of this wider wide bandwidth setting of the BladeRF, I'll make sure that I add that into DragonOS. All right, thanks.